In this problem, we're given the cosecant of the angle alpha and told that is in quadrant 4 from the looks of it, and the secant of the angle theta, and that's in quadrant 2. We're asked to determine the cotangent of alpha minus theta. You might think, well, I don't know the cotangent identity, but we really do, since cotangent is just 1 over tangent. Cotangent is 1 over tangent, and that goes for any angle you can think of. This is going to be true. So actually, let's just make some room here and put it in terms of the angle we're dealing with, which is the strange alpha minus theta angle. And that's going to be alpha minus theta. So you see, if we can find out what the tangent of alpha minus theta is, we just need to flip that upside down and we get the cotangent of alpha minus theta. So we're talking about a tangent identity in this problem. So first thing I'm going to do is make some triangles. Okay, standard procedure. Quadrant 4 triangle. That's going to look something like this. Okay, I'm just going to put a triangle over here. And I say that the cosecant. Well, what's cosecant? That's 1 over sine. So that's going to be hypotenuse over opposite, right? If this is alpha right here, the cosecant of alpha, according to what I drew, is -7 over 6. Now, the only problem is this picture doesn't make any sense at all, because you can't have a negative hypotenuse, right? That's not allowed. So we just need to change this around a little bit, so we still get -7/6, but we don't do it in a way that's violating basic geometry. And what I'm going to do is just take that negative sign from there and move it over to the 6. And now this actually makes sense, because I have 6 down, that's a negative direction in y, and a absolute value of 7 on the hypotenuse. So that's great. A little Pythagorean theorem will lead us to square root 13 on the x value. Double checking that. Yep, that's good. And on the next angle, this is in quadrant 2. Okay, actually, let me give myself a little more space here. Quadrant 2, here's my triangle there. And the secant is -4 over 15, root 15. So if the cosine is adjacent over hypotenuse, that means secant is hypotenuse over adjacent, which you might say is -4 over root 15, but remember the same reason. We have to make sure the negative sign is not on the hypotenuse. It's not allowed there. And if you calculate this one, you'll see that gives you secant equals 4 over negative root 15, which is the same as -4 over root 15. Okay, so that's good. Now, I just need to complete the triangle using the Pythagorean theorem, which looks like that's a distance of 1, that vertical direction. And you see this, the shape that I just drew makes very little sense. I mean, 1 looks almost as long as 4 in this example. Who cares? We're just using this as a little diagram to keep track of all our numbers so we don't lose track of things. Now, tangent, right? Remember what the tangent identity says. Tangent of alpha minus theta equals the tangent of alpha minus the tangent of theta all over 1 plus tangent alpha tangent theta. So now our job is to just put in what tangent of alpha and tangent of theta are into this problem. So let's do that. Actually, make it a fraction back here. Here's my fraction. And on the bottom, I've got 1 plus something. And on the top, I've got a minus. So alpha, tangent of alpha, I should say, is, let's see, that's going to be -6 over, opposite over adjacent, that's going to be -6 over root 13. And tangent of theta, what do we have here? That's going to be, well, -1 over root 15. You see, I didn't write 1 over negative root 15. There's nothing wrong with writing that. It's just that I didn't want negatives on my denominators. It's annoying to keep track of. And now I multiply those two fractions together. So I have -6 over root 13 times -1 over root 15. Okay. Now, this is awkward looking, to say the least. I've got compound fractions. And what I want to do to deal with this is I'm going to multiply top and bottom by root 13 times 15. Okay, root 13 times 15. This is my way of clearing the denominators. So let's see what we get as a result. The top left, the red fraction right here, that's the one I'm looking at now. That times this factor becomes -6 times root 15. Okay, and we go over to the next one. That's going to be positive 1 over root 15, which means positive root 13 once I carry through that multiplication and carry through the multiplication on this side, and we get root 13 times 15. And then it looks like this is going to be plus simply the number 6. Okay, so that is as far as I can go. There's nothing to simplify in terms of the radicals, right? You might be looking at this one, like maybe we can simplify that, but 15 can't be square rooted, right? That's just 5 and 3, and 13 is a prime number, so no help there. We're done with tangent. All that's left is to write the cotangent of alpha minus theta. And that's going to be simply this fraction flipped upside down. 13 times 15, you can certainly put in what that value equals if you want. I'm just keeping it here so it's very clear where all the numbers are coming from. And then -6 root 15 plus root 13. And there we go. That's our answer.